Hi, I'm Ayushman. At a quiet site far from the city, a radio telescope runs day and night. It does not receive TV. It measures faint radio emission from the galaxy, and almost every morning it detects hydrogen gas thousands of light years away. Here is the whole setup in one picture, so you know where we are going. The dish focuses the sky onto a homemade aluminium can feed. A filtered LNA boosts the signal right there. Then thick, low-loss coaxial cable carries it into a shielded metal cabinet. Inside sit the ASPI SDR, a Raspberry Pi that records around the clock, and a cellular router. Every device has its own battery backup. The mains comes in through a smart plug mounted outside the box, and the whole thing dials home over the internet on its own. So, what is it actually detecting? Most of the ordinary matter in the universe is hydrogen, and cold hydrogen gas drifting between the stars emits radio waves at one exact frequency, 1420 MHz, the 21 centimeter line. A single atom radiates maybe once in 10 million years, but space holds so many atoms that the whole Milky Way emits a faint signal at this frequency. That signal passes straight through clouds, through daylight, and even through dust that would stop ordinary light. This is the telescope, a 2.4-meter mesh dish. It runs observations 24 hours a day. There is no motor. It is aimed at a fixed direction, and the rotation of the Earth sweeps the sky through its beam, a full circle each day. Astronomers call this a drift scan. It sits at a remote site, because in a city, every phone and every Wi-Fi router would drown the galaxy completely. At the focus is the feed, and this is my favorite part, because it is literally an aluminium can, a 150 mm cantina, built at home, with a small probe inside at just the right spot. Here is how it works. The radio wave enters the can, reflects off the closed back, and forms a standing wave. The probe sits where the wave is strongest. I tuned it on a nano VNA until it matched cleanly at 1420 MHz. And yes, it passed inspection by Tom, the resident cat. The most distant hydrogen this dish reaches began its journey to us before the first pyramid was built. It has been traveling toward this dish the entire time. The hardest part of this hobby is not distance. It is radio frequency interference, or RFI. The hydrogen signal is extremely faint, while almost everything we build is loud in radio. So the whole station is built to stay radio quiet. The electronics sit sealed inside a shielded metal cabinet. Every Wi-Fi radio is switched off, and even the smart plug that powers it is kept outside the box, with the cellular antennas on short leads. The site is unattended, so the observatory is built to run on its own. It connects back to me over a private network and uploads a full day of data every morning. Its core system is kept read-only, so a power cut cannot corrupt it, and a spare boot drive waits in case the memory card ever fails. After any outage, everything simply starts again. So what does it see? This is one full day of Earth's rotation, the beam drawn across a real photo of the sky. Watch where the track lights up, exactly where it crosses the band of the Milky Way. Twice a day, the beam cuts through our galaxy's disk, and the hydrogen signal rises sharply. That bright crossing on the right lies toward the Perseus arm, the next spiral arm out from ours, roughly 6,000 light years away. Here is that same day in 3 dimensions. Every ridge is hydrogen gas, and the 2 tall peaks are the moments the beam swept across the plane of the Milky Way. And this is the daily result: the live spectrum, the day's waterfall building up, and the beam moving across the sky. Every peak is cold hydrogen, shifted in frequency by the rotation of the galaxy itself. I upload one of these scans here at least once in every week. A satellite dish, an aluminium can, and a shielded box built to keep the interference out. That is my small homemade radio observatory.